Good morning everyone. Welcome back to grade 5 mathematics class. How are you all doing today? So we have already learned about finding out the area of different shapes, and we had seen how we can find out the area of small figures using square grids. So today we'll see how we can find out the area of a few irregular shapes using a square grid. So look at this picture given here. You see, this is not a regular shape. It does not have any regular sides. It is a very irregular shape. How do we find out the area of this one? We cannot apply any formula here. So we are going to place this figure here on a square grid as the first step. So the first step is to place the shape on a 1 by 1 square grid. A 1 by 1 square grid means it has got a side of 1 centimeter each. So this side will be 1 centimeter and this side will be 1 centimeter. Here also 1, here also 1. So that is what 1 by 1 means, and hence the area of each square will be 1 into 1 or 1 square units. Now we have placed this figure here on this square grid. Now what is the next step? How do we find out? See, we have seen a few examples before in the beginning of the chapter. We are supposed to count the squares which this figure covers, right? So let's see how we can do the counting part. So to count the number of squares, first you have to count the number of squares which are completely covered by this figure. For example, see, this square is completely covered by this figure. So you can count that one, this one, here, 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 like this. First you have to count all the squares which are completely covered by this figure. So in the figure given here, which is in page number 147 of your textbook, the number of complete squares covered are 24. You can count them in your textbook. Now, what about the squares which are not completely covered by the figure? So in that case, squares which are covered more than half by the figure can be counted as 1. And which are covered only half can be counted as half. And which are covered less than half can be ignored. So here you can see a few squares are covered more than half, like this one, this one. Such squares can be counted as 1, and squares which are covered in half can be counted as half. Now, squares which are covered less than half, like this, these can be ignored. So here in this picture, the squares which are covered by half or more than half were 10. So we had counted a total of 24 complete squares. So we have to add these two. So that is the next step. So 24 plus 10 half squares or squares which are covered more than half. 24 plus 10 is equal to 34. So in the case of figures like this, we cannot measure the exact area of the figure using a square grid. We can have only an approximate value that can be obtained as the area of the given figure. Area of an irregular shape like this. The smaller the size of the squares of the square grid, the more accurate will be the area of the given irregular shape. Now you can read this topic in page number 147 of your textbook. Now we'll do one activity which is given in the same page. It's the target Olympiad activity. Now here you can see a set of 3 figures here. A question is given in the next page. Complete the given figure so that the area of figure 1 is 8 square units, figure 2 is 21.5 square units, and figure 3 is 24.5 square units. The first one I'll give as an example. In the first figure, the figure is not complete. So out of the squares that it covers here, let's count the area. So here it is 2 complete squares. So it is 2 plus, and we can see 2 half squares. So 2 halves can be counted as 1, and here also you can see 2 halves. So here the total area would be 4 square units. So this figure covers an area of 4 square units, but we have to complete this figure so that the area will be 8 square units. So we have 4 square units with us now. We have to add 4 more square units, which means we have to add 4 more complete squares. So this figure can be completed like this. See, Now we have a complete figure, and what is the area now? We have how many complete squares? 1, 2, 3, 4, 5, 6 and then 2 halves. Make 1. So that becomes 7. Here also 2 halves. That means 1. So it is 1, 2, 3, 4, 5, 6, 7, 8. Now the area is 8 square units. So similarly, you have to complete the other two figures so that the area of the respective figure will become equal to the one given in the question. So you do this as an activity now. Please pause this video, finish it and come back. Hope you are done with that. Now let's see the figure number 2. So here, what is the area of the figure from the question given? So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is 12 complete squares plus 2 halves, which is 1. So it is 12 plus 1, 13. Then here 1 half. So here in the figure given, the area is 13.5 square units. But we have to redraw this picture, complete this picture to make it 21.5. So how do we add squares to it? What is the difference between 21.5 and 13.5? The difference is how much? 8 squares. So we can add 8 more complete squares to this picture. How? See, right now we have 13.5. We are drawing a line here and we are drawing a line here also. So now we have added how many extra squares? 1, 2, 3, 4, 5, 6, 7, 8. So to this 13.5 square units, we have added 8 more square units. So now the area is 21.5 square units. Now what about figure number 3? How would you complete this picture so that the area will become 24.5 square units? Let's see what is the area at the moment. See, here it is. How many squares? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So right now we have 22 complete squares plus 2 halves. 2 halves make 1. So it is 23, then 23.5. We have to make it 24.5. The difference is 1 square unit between 23.5 and 24.5. So let's add one more complete square here, like by drawing like this. So right now we have, see how much? 23 complete squares, then 2 squares, 2 half squares, which make 24, then 24.5 here. So now we have completed the figure to make it having an area of 24.5 square units. I hope you got this clear. Now let's move on to the next activity. In page number 148, you can see this picture there. You have to find the area of the shaded portions if the area of swimming pool, lawn, playground and car parking are the same. So you can see this figure there, and the area of the swimming pool, playground, car parking and lawn are the same as mentioned in the question. The shape is also the same. So the dimensions should also be the same. So what is asked in the question? You have to find out the area of this shaded part, the part shaded in yellow color. How do we find out the area? So we know this whole length, but we don't know this length. But we know something else. See, this total length here and here is the same. So if this is 50 meter, this whole length should also be 50 meter. So till here, from here to here, it is 50 meter. And we know till here, it is 20 meter. So since these two have the same area, if this is 20, this should also be 20 meter. So we know this is 20, this is 20 and the whole length is 50 meter. How do you find out what is the length here? So this is 20 plus 20, 40. Then this whole length 50 minus 40 is 10 meter. So this length is going to be 10 meter. So this length is the same as this length. So here also the length should be 10 meter. Now, what about this length? See, till here to here it is 30 meter. So, here also it should be 30 meter. Now, here it is again 30 meter. So, here it should be 30 meter. Now, see, this length and this length are the same. So, here it should, if this is 10 meter, it should also be 10 meter. And here also it should be 10 meter. So, now let's split this shaded portion into rectangles like this. So, we can find out the area of this rectangle, this one and also this one, and add them all together to get the area of this shaded part. So, what is the area of this rectangle? Here it is 10 and here it is, see, the same length 30. So, here the area of this rectangle is length into breadth, which is 30 into 10, that is equal to 300 meter here, and here also it is the same. So, this is also having an area of 300 meter. Now, what is the area of this rectangle? The breadth is 10 meter and the length is the same length. This length is 50 meter and this length is 10 meter. So, the area should be 50 into 10 or it is equal to 500 meter. Now, we have to add the area of this one and this one together to get the total area of the shaded part. So, this is 300 plus 500, which is equal to 800 plus 300, and it is equal to 1100 square meters. So, that is the area of this shaded part, which is shaded in yellow color. You have to look into the picture in the textbook, and once again you have to work it out yourself in your notebook. Now, the next one, you can see this box, enrich yourself. Let me read out the note to you. The area of this rectangle is L into B equal to 12 into 8 or 96 square centimeter. The diagonal BD divides the rectangle into two triangles of equal area. So, what is the formula for finding the area of a triangle? It is 1 by 2 into base into height. Here it is 1 by 2 into 12 into 8, and that is equal to 48 square centimeter. Now, I'll explain to you what this means. See, you can see a rectangle here and it has got a length of 12 centimeter and 8 centimeter as the breadth. Now, this rectangle has this diagonal DB or diagonal BD, and this diagonal is dividing this rectangle into two equal halves or two equal triangles. Now, to find out the area of a triangle here, either this one or this one, what we used to do, we used to find out the area of the rectangle and then we divide it into half to get the area of the triangle, right? So, we have seen that the area of a triangle is equal to half the area of the rectangle formed by it. Now, here it is said 1 by 2 into base into height. So, we have already seen the formula 1 by 2 into length into breadth, which is the area of the rectangle. Now, here it's saying 1 by 2 into base into height. So, what do you mean by base? You see this side here, which is perpendicular to the height of this triangle. So, this side, which is perpendicular to the height of the triangle, is called the base of the triangle. And here in this case, this base is the same as the length of the rectangle here, and the height of this triangle here is the same as the breadth of this rectangle. So, in general, you can say the area of a triangle is equal to 1 by 2 into base into height of the triangle. So, that's a general formula. You have to keep this in your mind and make a note of it in your notebook. Now, you have to go through the topic area of irregular shapes in page number 146 and 147 of your textbook. Then, you have to complete the exercise 9.4, which is in page number 147. And then, in page number 148, you can see the heading My Project. Please go through it. And in the next page, page 149, we can see two activities given there. One is Fun with Maths, which is a fun crossword activity. And then the next one is a Maths Lab activity, which is an activity to find the area and perimeter of rectangles, squares and triangles. So it will be fun to go through it. So please go through it and do accordingly. So once you're done with these activities, you can take a picture and send us to Teams. So children, that's all for today. I hope all the concepts and the exercises we learned in this chapter are clear to you. In the next class, we will have a revision session. So make sure you go through all the topics once again and then come back to the next video. So that's all for today. We'll meet in the next class with a new topic. Till then, bye.